Hello, my name is Robert Fenn. I'm a product manager for Marvell's Fiber Channel product line, and I want to discuss two aspects of how Marvell's QLogic Fiber Channel host bus adapters work better together with Dell 17G servers, Dell PowerStore and PowerMax storage, and Dell's Connectrix MDS switches manufactured by Cisco. First, I'm going to discuss fiber channel SAN congestion and the key factors that could cause congestion, even in finely tuned SANs. First, enterprises tend to upgrade one end of the data center at a time. For example, upgrading to flash storage AFAs with 64 gig fiber channel interfaces, while still running older servers with 16 gig fiber channel interfaces. This may cause mismatches in server performance with storage endpoints. For example, servers might bite off more than they can chew. And extending the lifetimes of data center equipment only exacerbates this potential issue as speed gaps will widen further over time. Also, dynamically moving workloads around the data center to do more with less and balance endpoint compute and memory utilization may further disrupt storage network performance and tuning. And finally, older equipment wearing out may degrade performance, for example, fiber cables breaking and SFPs getting dirty. Fiber channel industry has adopted what's called fabric performance impact notifications, or FPINs, to allow switches to communicate congestion to fiber channel HBAs. This is implemented in the latest fiber channel hardware. And FPINs tell everyone in the zone exactly who is the compression culprit, and that is who is impeding other servers' performance. And mitigating congestion offending server will relieve the congestion to the other servers and storage endpoints in the zone, which are typically referred to as congestion victims. This highlights one of the values of identifying the source of congestion. It's not always obvious where congestion is. For example, if your application is running slowly, you don't know a priori if your application server is congested or another server in the SAN is causing congestion. And FPIN provide the clarity needed to resolve these fiber channel SAN congestion issues. The solution is for servers and storage to work together with the switch to quarantine traffic to the slow lane, then throttle its reads and writes to the storage array. Then after congestion is resolved with throttling, the traffic can be moved back to the normal lane. As on a highway, SAN congestion gets created when fast and slow devices are sharing the same highway or fabric. One challenge that storage administrators face now is integrating super fast and efficient native NVMe all-flash arrays with legacy SCSI traffic to older storage arrays. Under normal circumstances, the fiber channel HBA port to switch connection is like a single lane road with a finite number of buffer credits available for all traffic. Congestion occurs when slower devices starve the faster traffic of the availability of buffer credits, creating what's called a slow drain congestion. This can slow all workloads and thus be very hard to detect. So there needs to be more intelligence added to the equation, and that's where Marvell's USCM and FPINs come into play. Marvell has implemented technology available in the QLE 2770 and QLA 2870 series HBAs called Universal SAN Congestion Mitigation, or USCM, in which Marvell QLogic HBAs utilize FPINs to detect and mitigate SAN congestion. This includes Marvell's unique virtual lane firmware and hardware implementation, along with I/O throttling. For example, when there's congestion, the driver switches the session associated with the slow drain device to a slow virtual lane and throttles the I/O request to that device. Both Marvell HBAs and Dell Connectrix MDS switches now support virtual lane technology, which enables SAN traffic to be segmented into 3 different lanes: normal, slow, and fast. This allows slow traffic to be quarantined from faster, higher priority traffic, like trucks using the slow lane to allow faster cars to pass easily on the highway. Each virtual lane can carry a different storage protocol or a different session within the same storage protocol. At this point, I would like to switch to discuss how Marvell QLogic adapters will incorporate a silicon root of trust technology that prevents malicious firmware from hijacking the fiber channel adapter. This defends against unauthorized software accesses and changes to configuration of server and storage HBAs. At each boot or firmware update, Marvell QLogic adapters perform a firmware verification operation using the integrated Marvell public key to authenticate signed firmware. Servers secure their own firmware along with firmware of all adapters, which enables a chain of trust that extends from the motherboard across all adapters, providing a cohesive security architecture that protects the server against hardware and firmware-based threat vectors. This in turn provides a trusted foundation for additional layers of security, such as secure boot. Marvell ships a feature in HBAs called store encryption, which supports the fiber channel security protocol called FCSP. This adopts the IKE v2 protocol used in IPsec to autonomously, seamlessly, and transparently authenticate endpoints, generate random session keys, negotiate security associations, and encrypt data in flight across a fiber channel SAN, all while maintaining end-to-end data protection. Marvell Store encryption also eliminates the need for server-based encryption solutions that consume post-CPU cycles, for example, encrypted file systems, encrypted databases, and disk encryption software, while allowing storage arrays to continue featuring their value-added features, such as data reduction and deduplication, along with encrypted data at rest. Furthermore, Marvell HBAs can operate in conjunction with Connectrix MDS switch-based ISL encryption. Marvell Store encryption architecture also features CNSA 2.0 public keys, which are embedded securely within a hardware security module to enable verifying Marvell fiber channel firmware with CNSA 2.0 signatures. And when FCSP3 becomes available, featuring SPDM certificates for endpoint authentication, Marvell Store encryption architecture is ready. I want to thank you for your time and your consideration of how Marvell HBAs can work better together with Dell server switches and storage.